So in this video, I want to go through an exam style question, and we have the following values of x are exact and the values of f of x have been rounded to 3 significant figures. So we have a little table of results here. So part 1, find the maximum possible range of values of 2.57 take away 2.56 over f of 2.57 take away f of 2.56. Okay, so first of all, let's look at the range of values of f of 2.57 and 2.56. So f of 2.57 is this value, this value here, 2.57, is this value, but this has been rounded to 3 significant figures. So the lowest that could possibly be is 0.03365, and the largest it could be is 0.03375. So inclusive, not inclusive. Whereas f of 2.56, so using this value, the smallest it could be is 0.03335, so 0.03335, and the largest is 0.03345, so 0.03345. So for this calculation, so 2.57 take away 2.56 over f of 2.57 take away f of 2.56. Well, let's not get ahead of ourselves. Might not be a square bracket. So we know that the numerator will just be 0.001. Sorry, 0.01, rather, not 0.001. 0.01. And the denominator, because we want the overall value to be as small as possible, we want the denominator to be as large as possible. So we're going to want this one to be as large as possible and that one to be as small as possible. So we want to use that one, take away that one. So so I'll write that down, 0.03375 take away 0.03335. That's going to be a rounded bracket. So let's actually figure that out. So that's 0.01 divided by 0.03375 take away 0.03335. And that's 25. Okay. Then we want it to be as large as possible. The numerator is still 0.01. Now, to get as large as possible, we want the denominator to be as small as possible. So we want this one to be small, that one to be large. So we want to go with the smallest, take away the largest. So 0.03365, that one, take away 0.03345. So 0.01 divided by 0.03365, take away 0.03345, and that's 50. Okay, so the gap between the two values is actually 25. So from 25 up to 50, neither of which are included. So what you could write, if you wanted to write it as an inequality, would be 2.57 take away 2.56 over f of 2.57 take away f of 2.56. I should have written it a bit more in the middle. That would be, that's the 50, that's the 25. So it's between those two values. So explain why the range of values is large. Well, the reason for that is because the calculation required us to look at dividing by two values that, when you're subtracting, are quite close to 0. Okay, so the calculation involves the subtraction of nearly equal values in the denominator. So you're getting close to dividing by a very small number that's close to 0, and that obviously then balloons up your total value. Number 3, explain whether the maximum error of 2.57 take away 2.56 over f of 2.57 take away f of 2.56 is the same as the maximum error of 2.57 over f of 2.57 take away 2.56 over f of 2.56. So these look similar, don't they? And they both involve subtraction and division, but they're not the same. We know that you can't just split fractions out that way, okay? So what's happened is that the order of the calculation has changed, but not just that. Those two things aren't, even if you were just changing the order of operations, these two expressions are not equal. So the two expressions are not equal, and the order of operations has been changed. So no, the maximum error will not be the same. Okay.